Hi, my name is Karthi Gupta, and one thing that I've noticed is that developers joining a new project often spend hours or even days trying to understand an unfamiliar codebase. They need to read documentation, trace dependencies, identify important files, and understand how different components interact. That's the problem codebase memory solves. Right now, I've pasted one of my own repos into this. Now, codebase memory automatically clones the repositories, parses the code, extracts relationships, generates embeddings, identifies architectural patterns, and builds a knowledge graph of the entire project. Unlike traditional code search tools, we're not just indexing text, we're building a structured understanding of the repository. During ingestion, we analyze files, functions, imports, dependencies, architectural roles, and repository concepts to create a searchable understanding of the codebase. Now, while the insights are loading, let us look at the graph. We can visualize relationships across the codebase. This makes it easier to understand how files interact and which components they are connected with. They are separated into front-end, back-end configuration, and various other paths. Now let us look at a file called, let us take allocator.py. We can summarize the file to generate a concise explanation of its responsibilities, major functionality, and role within the system. For example, this file implements a volunteer allocation engine that optimally assigns volunteers to needs using a Hungarian algorithm, expanding multi-volunteer needs into individual slots. And another feature is that for clusters, we can also summarize the cluster. This system can help developers understand entire subsystems instead of individual components, as you can see over here. Now, one thing unique about the codebase is that instead of forcing developers to manually explore hundreds of files, codebase memory immediately explains what the project does, its architecture, technology, and major concepts. For example, Ferried is a platform designed to connect NGOs with volunteers for aid and relief efforts. This gives developers a high-level understanding before they ever open a source file. Now, there is this codebase assistant as well. We can ask things such as what does the repo do, which is stated before, but this is just to verify what this actually does. It uses a rack pipeline, so the context is repository specific. Now, as you can see, the repository contains code for Ferried, a web application that connects non-governmental organizations with volunteers to relief aid. And now, as you can see in the background, some of the risks and suggestions, info, warnings, all of that is also loading. This is because codebase memory doesn't just answer questions about the repository, it also acts as a code reviewer. It analyzes architectural components, it automatically surfaces potential risks, bottlenecks, and areas that may require attention that helps developers identify issues before they become a production problem. For example, let us take a risk. For example, the backend core Gemini has a maximum cyclomatic complexity of 17. We can check this file and actually see if it has a risk or if it's critical or not. And now one of the main things is that we can also it can also suggest us features. For example, the feature recommendation, volunteer availability calendar. Implement a calendar feature that where volunteers can proactively mark their availability. This helps the developer to find out what they want to make and include new features as well. Thus, codebase memory transforms large repos into searchable, understandable knowledge bases, helping developers spend less time exploring code and more time building software.